Hello, my dear friends. Let us continue learning. Probably in the last session, few programs you have done. We will have to continue learning few more programs in this session also. So, please take the heading as algorithm based programs. Below that, take the question. Write a Java program to search an element in an array. Yeah. Carefully watch this now. Say supposing, just an assumption, you have an array like this. Now, inside the array, you have the elements like this. Possibly, you have the elements as 10, 20, 30, 40, 50 and 60. This is array ARR1, just an assumption. This is 0th index, the first index, second index, third index, fourth index and the fifth index. Like this, say supposing you have an array and inside that contents also you have. Now you have to search whether an element called as probably 50 is present or not. Inside this array, whether an element called as 50 is present or not, that you have to search. If it is present, you have to tell yes, the element is present. If it is not present, you have to tell element is not present. Correctly tell me, is 50 present in this array? Yes, it is present. How did you search and tell? Well, you have started. 50, is it matching with this? It is matching. Just because 50 is matching with this, you told, yes, element is present. The same logic you have to apply here. And remember, whatever the element you are about to search in programming, it is called as key. So now you have to search whether this key is present in this array or not. How will you search? Searching is very, very easy. First, take that key and compare with the element that is present in array of 0. Start from the first element there. If it is matching, then tell yes, element is there. If it is not matching, don't come to conclusion that element is only not there. Still array is there, no? Continue until end. Check again whether this 50 is matching with array 1 of 1 or not. It is not matching. Continue ahead. Whether 50 is matching with array 1 of 2 or not. It is not matching. Continue ahead. Whether 50 is matching with array 1 of 3 or not. It is not matching. Continue ahead. Whether 50 is matching with array 1 of 4 or not. Yes, it is matching. If it is matching, tell key found. Else, tell key not found. As of now, it is matching, tell key is found. On the other hand, say supposing you want to search for an element, possibly 100. Whichever the element you want to search, that is called as key programmatically. Whether this key is present in that array or not, you have to search. Well, how will you search? Follow the same approach. Start from the first element, means 0th index element. Whether this 100 is matching with array of 0 or not. It is not matching. 100 is matching with array of 1 or not. It is not matching. Whether this 100 is matching with array of 2 or not matching. 100 is matching with array of 3 or not? Not matching. 100 is matching with array of 4 or not? Not matching. 100 is matching with array of 5 or not? Not matching. 100 is matching with, element only is not there. We have come out of the boundary of the array. Boundary of the array is just 5th index. We have come out of the boundary of the array. Always remember, in searching process, if you will come out of the boundary of an array, you can clearly tell that the element or the key is not found. If key is there, it should always be present inside the array. While searching, if you will come out of the array, then key is not found. The same thing programmatically I have to do. Means one array will be there, inside that elements will be there. User will ask me to search for a key. I have to search. While searching, if key is there, I have to tell key is present. While searching, if key is not there, I have to tell key is not there. As simple as it is. If you will ask me, sir, how to tell, how to write the program, like this, you have to write carefully. Watch it. Very, very important program. How important is it? Probably by the end of the lecture, you will understand. I will directly start writing the class. This is that class called as demo. Inside the class demo, it is public static void main, which would accept string of args inside the main method. Certainly many inputs I would take. So before that, let me give the class name based on the task. That is how it has to be. We are doing searching, so I would tell class searching or class search I would tell. I have the main method. Inside that, because I will take many inputs, I have the scanner object. Sorry, I need the scanner object. Scanner scan equals to new scanner of system.in. Next, if I want to search an element in an array, first array must be there. To create an array, first length must be there. I will ask the user system.out.println. Enter array length. By seeing this message, the user will enter the array length. I would collect it by telling scan.nextInt. I would store it in a variable called as n, which is of type integer. I have the array length. Array I have to create of that length. So what I will do is I will create one array like this. I need a new integer array of the same length entered by the user. For that, let me give the name as ARR, which is of type integer. Of course, it is an array. I have an array, but inside that elements only is not there. If simply I have an empty array, what will I search for? So first I should have the contents inside it. I will ask the user to enter the contents like this. System.out.println. Enter array contents. By seeing this message, user will enter the array contents. I would collect it like this. Start collecting the content from 0th index. Go until array 1.length minus 1 I plus plus. Probably I will give the name as array 1 only. Here I would tell system.out.println. Enter an element. By seeing this message, user will enter an element. I have to collect it. I will collect it by telling scan.nextInt. I would store it in a variable or in the array ARR of the ith index. By the end of this loop, array would be ready. Inside that elements are also would be ready. Now what I have to do? I have to ask what key I have to search inside that array. What key I have to search? I have to ask. So that is what I would tell. System.out.println. Enter key to search. By seeing this message, user will enter the key to search. Probably I have to collect it by telling scan.nextInt, and I would store it in a variable called as key, which is of type integer. Now if you carefully see, array I have, inside that contents I have, key, what to search also I have. Now I have to search it, I have to perform searching. Correctly tell me whether that key is present or not. You are about to search. From where you have to start searching? From 0th index you have to start searching. Until where you have to start searching? Until end you have to start, until end you have to search. Well, what if you will cross the end? That is the next issue. But until end, if you have to continue searching. Every time you have to go ahead and search, ahead and search, ahead and search, ahead and search, ahead and search. Same thing I will tell here. Look, start searching from 0th index. Go until I less than or equals to array's length minus 1. Every time go ahead. Every time what are you doing? Very simple. What did you do? Whether key is matching with array of 0 or not, you checked. It was not matching. What did you do? You went ahead. Again, what did you do? Whether key is matching with array of 1 or not, you checked. Did it match? No. What did you do? You went ahead. Whether key is matching with array of 2 or not, that is what you did. You have started searching from 0. You will go until last. But every time what are you doing? You are just checking if at all the entered key is matching with the array of I or not. If I is 0, key is matching with array of 0. If I is 1, key is matching with array of 1. If I is 2, key is matching with array of 2. Say supposing it is not matching every time. See? I is 0, key is not matching. Say supposing it is not matching, you come out, I++. There also key is not matching with array of 1, you will come out, just an assumption, I++. I will become 2. Key is not matching with array of 2, you come out, I++. 3, key is not matching with array of 3, say supposing it is not matching, you come out, I++, I will become 4. If key is not matching with 4 also, say supposing it is not matching with array of 1 of 4, you come out, I++, I will become 5. If key is not matching with array of 5 also, you will come out, I will become 6. Is 6 less than or equals to 5? No, it is not less than or equals to 5. 6 is more than 5, you come out of the entire for loop. Am I not correct? Coming out of the for loop is nothing but going out of the boundary. When control will come out of the for loop? When I become 6. See, until 5, you will be inside the array. If you become 6, you are going out of the array. If I is 6, you are coming out of the for loop. If you are coming out of the for loop, it is nothing but you have crossed the boundary of the array. If you are crossing the boundary of the array, what do you mean by that? Key not found. Until unless you are inside the for loop, there is all the possible chance that key may become equal to array of some index. We can tell, if it becomes equal, we can tell system.out.println key found at the index whatever is there in I. We can tell. What is that, sir? Key found at the index I. Say supposing this example only I will take 50. I is 0. Is key matching with A of 0? No. Come out. I++. 1. Is key matching with array of 1? No. Come out. I++. 2. Is key matching with array of 2? No. I++. 3. Is key matching with array of 3? No. I++. 4. Is key matching with array of 4? Yes. Is 4. Is key matching with array of 4? Yes. system.out.println key found at the index 4. Correct. Key found at the index 4. Say supposing if this is the case, 0 also it will not match, 1 also it will not match, 2 also it will not match, 3 also it will not match, 4 also it will not match, 5 also it will not match. I will become 6. I is becoming 6 means you are going out of the array. If you are going out of the array, then it is nothing but key not found. Correct. See, where is 100? Not found. Going out of the array, programmatically it is nothing but control coming out of the for loop. So, if control comes out of the for loop, I can come to that conclusion where I can tell key not found. Like this. System.out.println key not found. This is the opening of the main method. This is the closing of the main method, closing of the class. Work is over. Okay, sir, will it work? Will it work? We will see first. Many things I have to tell here. Still many things. Program is pending. Don't worry. First, let us execute and see. We'll execute. We'll open the Eclipse. We'll type the same program. Same program is typed. I would right click, run as Java application. It is asking me for the length. Probably I will give as 6 only, like this. 6 is the length. Enter an element 10, 20, 30, 40, 50, 60. Entered. It is asking for the key. I will give 100. First 100 I would give. Give 100. Key not found. Correct. One more time I will execute. Look at it. I will re-execute it. Again enter the length. Same 6 I would give. 10, 20, 30, 40, 50, 60. Done. Enter the key. Probably I will enter 80. Is 80 present in this array? Oh, it is not present. So what should be the output? Key not found. Enter. Key not found. Right. But if I will re-execute again, re-execute it. Again enter the length. 6 only I would give. 10, 20, 30, 40, 50, 60. Enter the key. I will give the key as 50. Do we have 50 here in this array? Yes. What should be the output? Key found at the index 4 should be the output. Correct? Enter. Key found at the index 4. And what are you telling? Key not found. Both the outputs are coming. Why? Very simple. According to the program that you have written, both the output will come. Program will start executing, it will take the length, it will create the array, it will ask the contents, it will ask the key, it will search. Say supposing key is present, key matched with 4. You told key found. Did you stop? No. Key matched with array of 4, you came inside, key found at the index 4, closing the if, you come out, see the closing bracket, you go back, I plus plus is 5. Is 5 less than or equal to 5? Yes, you come inside. Is key matching with array of 5? No. Come out. I become 6. 6 less than or equals to 5? No. Come out of the for loop and print this. What did we do pictorially? We started, continued, key found, we stopped searching. But programmatically, when we have written it, we did not stop. Even though key found, we continued searching. That should not happen. Key found. Stop the program. Don't continue searching. If you will ask me, sir, how to stop searching, sir? You have to tell system dot exit. In C language, you have seen this exit function. If you will ask me, sir, what this system dot exit does? When your control sees this system dot exit, it will directly take the control and it will come out of the program only. As soon as control sees this, it will directly go out of the program. It is not that it will go out of the for loop or something like that. It will stop the execution, your control will go back to OS. Correct. Once the key is found, why should I continue executing the program? I will stop the program. Stop the searching only. This program is all about searching. Once I found the key, stop searching. Control will come out of the program if you write system.exit of 0. Oh, really, sir? Show us, sir. Watch it. I'll open the Eclipse. That one line I would add, system.exit. If I will execute it, array length 6 only, 10, 20, 30, 40, 50. 60, of course. If I will click on enter, it will ask for the key. Probably here I would enter 50 again. As soon as I click on enter, look at the output. Key found at the index 4. After that, it did not continue searching, program halted. I hope I am completely clear about how to search a particular element or a key in an array. How did we search? We searched one after the other, correct? We started from 0, one after the other we have searched. See, we started from 0, one after the other we have searched. Like this, searching an element, whether it is present or not, one after the other. Like this, if you will search, in this manner, if you will search, in one after the other manner. Such type of searching technique is actually called as linear searching or sequential searching. This is what is linear search. Linearly, one after the other, searching whether the element is present or not in an array is only called as linear search. What do you mean by linear? Linear means one after the other. What do you mean by sequential? Sequential means also one after the other. So what program I have written now, if you will ask me, it is actually the linear search program. And whatever the logic you are seeing here, this only is linear search logic. This only is linear search algorithm. Start searching from 0, go until the length of the array. Every time check whether key is matching with array of the index or not, array of I or not. If it matches, then tell key found. If the control goes out of the for loop, tell key not found. This is the algorithm of linear search. I hope I am completely clear with what is linear search algorithm. This only is linear search algorithm. Directly I have written the code. Linear search code, this is this part. I hope I am completely clear. Below that, A, by using linear search. You have taken the question A, by using linear search. Copy this program as it is. The next program is very, very important. We will see it, but first copy this as it is. Be very, very quick. I hope you have completed it. If not, please do pause the video, complete it. Let us move ahead. See, probably, say supposing you have an array like this. This is very important discussion. You have an array, possibly like this. Inside that array, you have the elements like this: 10, 20, 30, 40, 50 and 60. Like this, you have some elements. These are the indexes 0, 1, 2, 3, 4 and 5. This is array ARR, just an assumption. Say supposing in this array ARR, you want to search one key. If you will ask me, sir, what is the key I have to search? Probably the key what you have to search is 30. 30 is the key that you have to search. How many comparisons it would take if you do it in the previous approach, means the linear approach. Just now we have learnt, no? In that approach, if you want to search 30, how many comparisons it would take? How will you do linear search? One after the other you will search and go. Like that, if you search 1, 2, 3 comparisons it would take. Am I not correct? On the other hand, if you want to search 300, just an assumption. Say supposing you want to search 300, whether it is present or not. How many, first of all, is 300 present? No, it is not present. To tell it is not present, how many comparisons you have to do? If you carefully see, 1, 2, 3, 4, 5, 6, 6 comparisons you should do. After doing 6th comparison only, you can come to that conclusion where you can tell that 300 is not present. Am I not correct? Yes or no? This is the problem with linear search. It takes quite a lot of time to give the result whether the element is present or not. Say supposing you have 100 sized array, 100 length array. The element is present in the last index. How many comparisons it would take? 100 comparisons it would take, because one by one from the first you have to go until last. 100 comparisons it would take if at all the element is present at last. If it is present at in mid also, at least 50 comparisons it would take. If the element is not present, after 100 comparisons, you will tell that the element is not present. What if the array length is 1000? If the element is in exactly mid of the array, 500 comparisons it would take. If it is at the end, 1000 comparisons it would take. If element is not present, after 1000 comparisons, we will understand that element is not present. How inefficient this algorithm you see. With respect to time, it is really very inefficient, because so many number of comparisons you have to do. Just because linear search is inefficient, we have one more searching technique called as binary search. If you will ask me, sir, what is binary search and how to do it? Certainly you will understand. Please do take the heading as binary search. Again, say supposing you want to search for key 30. In linear search, it will take 3 comparisons. You can see 1, 2, 3. Okay, sir, in binary search, how many comparisons it would take? Carefully watch it. This is what binary search algorithm is all about. First, you have to make one variable called as low to point to 0th index. That is how algorithm goes. That is what binary search algorithm, inventors told. Make a variable called as low to point to 0. Very easy, we can make it. Make a variable called as high to point to the last index of an array. What will be last index of an array? Array length minus 1, that will be the last index of an array. So initially these two things you have to do. Make a variable called as low to point to 0th index. Make a variable called as high to point to last index of an array. Once it is done, you have to calculate something called as mid, it seems. If you will ask me, sir, what is mid? Mid will always be equal to low value plus high value whole divided by 2. Well, what is low value? Low is pointing to 0. So, low value is 0. Sir, is it not 10? No, it is not 10. ARR of low might be 10. But low is pointing to 0. So, low value is 0. Okay, sir, what is high value? High value is 5. 0 plus 5 by 2 is 5 by 2. 5 is an integer, 2 is an integer. Integer by integer will always give you an integer. So, 2. So, mid becomes 2. Oh, correct, sir. Integer by integer is an integer. Mid is 2. means mid will start pointing to 2. Once you calculate mid, according to binary search algorithm inventors, they told, once you calculate mid, please check if at all the key is matching with array of mid or not. If it is matching, then please tell system.out.println key found at the index, whatever is there in mid. So let us check. We have calculated mid. Next I will check. Is key matching with array of mid? What is key? 30. Is 30 matching with array of mid? Mid value is 2. Is 30 matching with array of 2? Matching. Key found. How many comparisons I did? Only one comparison I did. Only one comparison I did. Nothing more, nothing less. Only one comparison I did. In one comparison, I am telling whether the element is found or not, whether key is present or not. See how efficient it is? I know some students will tell, sir, you are very intelligent, sir. Wantedly, you have taken the key as 30, sir. Because you know the algorithm. Low plus high by 2 will give you 2 like that, you know, sir. Wantedly, you have taken 30. Take some other number, let me see. Prove that it is efficient. Okay, say supposing this is the array. The same array I am writing. I have 10, 20, 30, 40, 50, 60, same array. The indexes also would remain same, 0, 1, 2, 3, 4 and 5. Name also would remain same. This time, because you are telling, sir, change the key, I will make key as 50. Say supposing I want to search 50. This. Whether it is present or not, I have to search. In linear search, how many comparisons I would have made? If you see 1, 2, 3, 4, 5 comparisons it would have taken to search whether key is present or not, 50 is present or not. Let us do it in this method, binary search method. What binary search people will tell? Make a variable called as low to point to 0, done. Make a variable called as high to point to array length minus 1, pointed. The last index, done. Calculate mid. Okay, calculate mid. Mid will always be equal to low plus high whole divided by 2. What is low value? Low value is 0. What is high value? High value is 5. 5 by 2 is 2. So mid becomes 2. Am I not correct? Mid becomes 2. Oh, correct, sir. Mid becomes 2. Next what? Once you calculate mid, what you have to do? That here also we have to do. What you have to do? Once you calculate mid, you have to check if at all the key is matching with array of mid or not. This you have to check. And if it is matching, sir, if it is matching, proudly tell that key is found at the index, whatever is there in the mid. Closing of the if. Okay, sir, let us check. Mid is 2, key is 50. Is 50 matching with array of mid? Is 50 matching with array of mid? No, 50 is not matching with array of mid. 50 is not matching with array of mid. This is 30. 50 is not equal to 30. If it is not equal, then what to do, sir? Once you calculate mid, check if key matches with array of mid. If it is matching, tell key found. Else, if it is not matching. If it is not matching, at least check whether key is greater than array of mid. What is key? See, check if key is greater than array of mid. If it is greater, say supposing key is greater than array of mid, then take low and make it point to mid plus 1. Let high be there only. What is that, sir? Nothing we understood. Watch it. If key is equal to array of mid, then tell key found. If it is not equal, then at least check whether key is greater than array of mid. What is array of mid? 30. What is key? 50. Is 50 greater than 30? Yes. 50 is greater than 30. If at all key is greater than array of mid, then take low and make it point to one level after mid. See, that is what I did. Take low, make it point to one level after mid. Mid was 2, mid plus 1 is 3. That is what I did. Make low point to one step ahead of mid. Let high be there only. High value previously also 5, now also 5. Let high be there only. Okay, sir. Next what? Always remember in binary search algorithm. Always remember. If at all low or high value changes, you have to again calculate mid. What was the low value previously? 0. What is the low value now? 3. Means low value changed. High value is same, but low value changed. If at all low or high value changes, again calculate mid. Like this. What is the mid? Mid will always be equal to low plus high by 2. What is low value? Look, what is a new low value? 3. What is high value? 5 divided by 2. 5 plus 3 is 8 divided by 2. 8 divided by 2 is 4. So, new mid is 4. This is a new mid value. Oh, okay, sir. Mid value calculated. Next what, sir? Whenever you calculate mid, again check whether key is equals to array of mid or not. Once you calculate mid, check whether key is equals to array of mid or not. Now I calculated mid newly. Again I would check. Is key equals to array of mid? What is key? 50. What is array of mid? 50. Is 50 equal to 50? Yes. Key found at the index, whatever is there in mid. Oh, key found at the index 4. Look at it. Key found, but how many comparisons we did? There is a difference between calculation and comparison. How many comparisons we did? Only 2 comparisons. First, here we did a comparison, then we did here a comparison. Only 2 comparisons, but key found. If the same thing we would have done in the linear search, 1, 2, 3, 4, 5 comparisons we should have done. Sir, again you are very, very intelligent, sir. Very intelligent you are. Just because you know the algorithm that low will come this side, low plus high by 2 will give this only you have taken, sir. Take this side, sir. Let me see any number. Okay, probably I will take 10. This one I would take. Say supposing this is the array. This is that array. I have 10, 20, 30, 40, 50 and 60. Like this. Indexes also I will keep it same. 0, 1, 2, 3, 4 and 5. This is array ARR. Now the key, whatever I want to search is 10. Key whatever I want to search is 10. What we have to do initially in binary search? By now this should have come to your mind properly. Initially, low should be pointing to 0th index. High should be pointing to the last index. That is what you have to do. Next what? Once low and high is fixed, you have to calculate mid. What is mid? According to us, mid is low value plus high value whole divided by 2. What is low value? Low value is 0. What is high value? High value is 5. What is 0 plus 5 by 2? It is 5 by 2, probably 2. Next, once you find the mid, probably mid will be pointing here like this. This is mid. Okay sir, next what? You know, once you calculate mid, what you have to do? What you have to do? You have to check if at all the key is matching with array of mid or not. If it is matching, you know what you have to do? You have to tell system.out.println key found at the index. Print whatever is there in mid. Because mid will be pointing to some index. There only if it is matching that index we are printing. Else, if at all the key is greater than array of mid. If it is not matching, we are checking whether it is greater than array of mid. If it is greater than array of mid, what are we doing? We are taking low, making it point to one level ahead of mid. Correct? Take low, point to one level ahead of mid. Let high be there only. Let high be there only. This is what pretty much we did. Am I not correct? Now let us follow the algorithm. We have calculated mid. So let us check. Is key matching with array of mid? What is key? 10. Is 10 matching with array of mid? No. 10 is not matching with 30. Okay. If it is not matching, at least let us check. Is key greater than array of mid? What is key? 10. Is 10 greater than array of mid? Is 10 greater than 30? No. 10 is not equal to 30, 10 is not greater than 30. Correct, sir? Then what we should do? If it is not equal also, if it is not greater also, what we should do, sir? If it is not equal also, and if it is not greater also, tell else. I don't have space here, so I am continuing here. Else, if it is lesser, then please make high point to one level before mid. Let low be there only. Let low be there only. That is what binary search algorithm inventors told. That if it is greater, take low, point to one step ahead of mid. If it is lesser, take high, point to one level before mid, like this. As of now, key is not equal to array of mid. Neither key is greater than array of mid. Key is less than array of mid. If key is less than array of mid, take high. Point to one level before mid. That is what it is. Mid previously was 2, 2 minus 1, 1. Correct only. One level before mid. Let low be there only. Let low be there only. And I have clearly told it to you. If low or high value changes, what you have to do in binary search algorithm? You will have to calculate mid again. So, mid value will always be equal to low plus high by 2. What is new low value? 0 only. What is new high value? 1 only. 0 plus 1 by 2 will give you 1 by 2. Integer by integer is always an integer. So, mid value will be equal to 0. Am I not correct? New mid value is 0. So, mid will stop pointing here. Mid will be pointing here. Sir, low is also pointing there only, sir. Let it point. What is your problem? Neither what should be my problem. Both are pointing to the same. Let it point. But once you calculate mid, what you have to do? Again you have to check whether key matches with array of mid or not. What is key? 10. Is 10 matching with array of mid? Is 10 matching with array of mid? Yes, 10 is matching with 10. Key found at the index 0. Key is found. I know most of the students will tease me, sir. In linear search, To find 10, only one comparison, no calculation. Here you see, sir, two comparisons, two calculations we did. Binary search is inefficient, no, sir. Here is where you have to understand something called as best case scenarios and worst case scenarios in any algorithm. Probably I will tell you by taking an example. Say supposing all your details, all your data of Gmail application, Google people have stored in an array. They have not stored in an array, don't think. But say supposing all your details, username, password, username, password, username, password, username, password, like that, you know. All your details, they have stored it in an array. And whenever you give username and password to log in into Gmail application, whether you are a user or not, they have to search in their array wherever they have stored. You have entered username and password. The same username and password, whether it is correct or not, they want to search in the array that they have stored. Assumption again, everything is assumption. Correctly tell me, if at all they have stored it in an array and they have implemented linear search algorithm to search, are you the first user of Gmail? So that first time only it will match and immediately you will get your inbox. Are you the first user of Gmail? How many of you will confidently say, I am the first user of Gmail? If at all you are the first user, then it is a best case. It is a best case that you are only first. Algorithm is linear search. At first comparison only you got the data. That is the best case. But out of so many people listening to this lecture, not even one person can claim that you are the first user of Gmail and your data is stored here only in the first index only. You are what millionth user, you only don't know. Am I not correct? So if they have stored it in an array and you are some millionth user, probably 10 millionth user you are, and if they have implemented linear search to search, 10 million comparisons you should have done. But if you go in binary search, the comparison should become less for the worst case scenario. Never you should judge the efficiency of the algorithm in the best case scenario. Always it will be in the first only you will get off. No. How efficient it is in the worst case. See here, 4-5 comparisons it would have taken if you do it in a linear search. But in the binary search, in 2 comparisons it is over. Worst case, it is efficient. Oh, correct, sir. If element is not there, how best it would be, sir? If element is not there, how best it would be? I would show you, don't worry. But below that, take the heading as binary search. Case 1, case 2, case 3. 3 cases also you write. This is very, very important, whatever I have written here. 3 cases also write. Don't come to any conclusion. Still nothing is completed. Case 1, case 2, case 3. First copy it as it is. Be quick. You have to be very quick. If at all you have not completed, pause the video and complete it. But I will erase the complete board and I would continue. Pause the video and complete it. We'll continue now. I know that one doubt you will still have, that if element is not found, then what to do? If element is not there, then what to do? Carefully watch it. Say supposing you have an array like this. This is an array. In this array, you have the same elements 10, 20, 30, 40, 50 and 60. Like this you have. This is array ARR. 0, 1, 2, 3, 4 and 5. Again I would rewrite the array, carefully watch it. I need it for the explanation purpose. The same array I am rewriting. 10, 20, 30, 40, 50 and 60. Like this. 0, 1, 2, 3, 4 and 5. This is the same array AR. Now just an assumption. The key, whatever I want to search now, if it is probably 100. If it is 100, correctly tell me, is 100 present here in this? No. But by using binary search, you have to tell it is not present. You have to search it in the binary search way and you have to tell it is not present. So let us search in the binary search way. Probably here I will have low, here I will have high, here I will have mid. Now calculations and all again and again, I don't want to make you feel bored. Initially low will be pointing to 0, high will be pointing to the length minus 1. Am I not correct? That is what I did. Low will be pointing to 0. High will be pointing to length minus 1. You have to calculate mid. Correct? That is what you have to do. You have to calculate mid. Probably mid value is low plus high by 2. 0 plus 5 by 2, it is 2. Am I not correct? So, mid will be pointing to 2. This is the condition. As of now. Yes or no? Yes. Now, once you calculate mid, what you have to do? You have to check. Look at this. First, you have to calculate mid by telling mid equals to low plus high by 2. Then you have to check if at all the key matches with array of mid or not. If it matches really very good, we will tell system.out.println key found at the index whatever is there in mid. Fantastic. Good. Now let us see. Key is 100. Is 100 matching with array of 2? No, it is not matching. If it is not matching, what we are doing? We are checking if at all key is greater than array of mid. If it is greater, we are making low to point to one step ahead of mid. We kept high there only. Am I not correct? This is what we did. Now, if it is not greater, if it is lesser also, we did something. If you ask me, sir, what did we do? We made high to point to one level before mid. We kept low there only. That is what we did pretty much. Now, after calculating mid, I would check if key matches with array of mid. Is it matching? No. If it is not matching, I have to search whether key 100 is greater than array of mid. Yes. Key is greater than array of mid. If it is greater than array of mid, what are we doing? We are making low to point to one step ahead of mid. That is what we are doing. So, I will make low to point to one step ahead of mid. Mid is 2, one step ahead of mid is 3. Let high be there only, no change. If low or high value changes, look, low and high value, which changed? Low value changed. If low or high value changes, I have to calculate mid. Let me calculate mid. 5 plus 3 is 8, 8 by 2 is 4. So, mid, new mid value is 4. This is new mid value. Once you calculate mid, again you have to check whether key is matching with array of mid or not. What is key? 100. What is array of mid? 50. Is it equal? No. If it is not equal, go and check, is key greater than array of mid or not? What is key? 100. What is array of mid? 50. Is 100 greater than 50? Yes. It is greater than 50. If key is greater than a of mid or array of mid, what we have to do? We have to make low to point to one step ahead of mid. Mid is 4, low becomes 5. Correct. See, make low point to one step ahead of mid. Make low point to one step ahead of mid. Sir, low and high pointing to same place, sir. Let it point. What is your problem? Let high be there only. Let high be there only. High previously was 5. Let it be there only. If low or high value changes, did low or high value changes? If low or high value changes, again calculate mid. 5 plus 5 is 10. 10 by 2 is 5. Mid is also 5. So mid also will start pointing there only. Mid also will start pointing there. Oh, okay, sir. Mid also we got. Next what? If you calculate mid, again you have to check whether key matches with array of mid or not. Is 100 matching with array of mid 60? No, it is not matching. Is 100 greater than array of mid? Yes, 100 is greater than 60. If it is greater, what you have to do? Make low point to one step ahead of mid. Mid was 5, ahead of mid is 6. Let high be there only. Please stop the algorithm. If you ask me, sir, why, sir? Why should I stop? Why? Because this low became greater than high. If you want, you can see. What is low value? 6. What is high value? 5. If low becomes greater than high, close your eyes until key not found. Correct only. You just checked whether key matched with A of mid or not. It did not match. So what did you do? You checked whether key is greater than A of mid or not. It was greater. So what did you do? You made low to point to one step ahead of mid. What is one step ahead of mid? Nothing. Whenever low becomes greater than high, then you can close your eyes and you can tell key not found. Correct. Where is 100 in the array? It is not there. It is not there. Until and unless low is less than high, there is a possible chance that you will get the key. If low becomes greater than high, you will not get the key. You can close your eyes and tell key not found. As simple as it is. Oh, sir, this side higher number you have taken 100. Take this side, sir. 5 you take and prove the same thing. 5 you take and prove, sir. Okay, I will take and prove. Watch it. Say supposing the key, whatever I want to search now, is actually 5. Key is 5. Let me have that low value, high value and the mid value. Now I will not even have those arrow marks written to the array. Everything should be running in your mind. Initially, low will be 0, high will be length minus 1. Calculate mid. What is mid value? 2. Check whether key is matching with array of mid. Mid is 2. Is 5 matching with array of 2? No. If it is not matching, check whether key is greater than array of 2. Is it greater than array of mid? No. If it is lesser, the only option is it will be lesser. If it is lesser, then make high point to one level before mid. What is mid? 2. High will be one level before mid. I am sorry. 1. 2 minus 1 is 1. Let low be there only. Let low be there only. If low or high value changes, calculate mid. What is mid? Low plus high by 2. 0 plus 1 by 2. It is 0. You calculated mid. Again check whether key matches with A of mid. Key is 5. Array of mid is 10. Is it matching? No. Check whether key is matching with array of, is greater than array of 0 or array of mid. Is it greater? No. If not equal, if not greater, what it will be? Lesser. If it is lesser, then make high point to one level before mid. What is mid value? 0. What is before 0? Minus 1. Make high point one level before 1. Let low be there only. So please stop. Why we have to stop, sir? Why? Because low became greater than high. If you want to see what is low value, 0. What is high value? -1. Close your eyes and write key not found. Close your eyes and write key not found. Correct. Where is 5 in that array? 5 is not there. Let us compare it with linear search. Whether 100 is there or not, if you want to search by using linear search, how many comparisons it would have taken? 1, 2, 3, 4, 5, 6 comparisons it would have taken. In binary search, how many comparisons it took? 1, 2, 3 comparisons only. Fourth comparison we did not do only. If 5 is there or not in this array, in linear search, how many comparisons it would have taken? 6 comparisons only it would have taken. But in binary search, 2 comparisons only. Third comparison I did not do. This is why I am telling you binary search is efficient when compared to linear search. Not only that, if you carefully see, some steps I am repeating in binary search. What steps I am repeating? This step only. Calculating mid, checking whether key is equals to A of mid, or checking whether it is greater than A of mid, or if it is less than mid. This I am repeating. How many times I am repeating? Can you tell me? Look at case 1, case 2, case 3. These cases also you look at it and you tell me how many times I am repeating it. In case 1, 2 times. In case 2, 2 times. In case 3, 2 times. Here, how many times? 3 times. Here, how many times? 2 times. If the array is big, how many times? Well, it depends. You are doing this again and again and again, calculating mid, checking whether it is equal, greater, lesser, all those things, you know, you are doing it again and again and again, but how many times you are doing that you don't know. It depends. It depends when until the key is found or if low is greater than or equals to high. Am I not correct? If key is found, we are stopping. Or if low is greater than or equals to high, whenever low is becoming greater than high, we are stopping. In these two conditions, we are stopping. Else we are always checking, calculating mid and doing that again and again. Am I not correct? So the algorithm is very, very simple. In binary search, you have to calculate mid. You have to check if it is equal or greater or lesser. You have to do this again and again and again as long as this low is less than or equal to mid. If as long as the low is less than or equals to mid, you have to do this again and again and again. In between, if key becomes greater than or equals to, if key becomes equal to array of mid, you will tell key found. Say supposing never until low less than or equals to high, never key became equal. Always you continue, suddenly low became greater than high. Like this. You calculated mid, checked, calculated mid, checked, calculated mid. But at some point of time, low became greater than high. If low becomes greater than high, control will come out. As soon as control comes out, you can clearly tell system.out.println key not found. Now whatever you are seeing here, this only is binary search algorithm. See, initially low will be 0, high will be array length -1. Am I not correct? Initially low will be pointing to 0, high will be pointing to array length -1. Then what you will do? You will calculate mid. After calculating mid, you will check whether key is equals to A of mid. If it is equal, okay, you will tell key found. If it is not equal, you will check it is greater or lesser. Again you will do this, again you will do this, again you will do this, again you will do this. As long as low is less than or equals to high. Low is less than or equals to high. Once low becomes greater than high, then you will come out and you will tell key not found. Whatever you are seeing here, this only is binary search algorithm. I hope I am completely clear. Below that, take the heading as stopping condition stopping condition. Copy this. Copy the algorithm. We have to convert the algorithm to code also. We have to make it working code. Copy the algorithm also. Be quick. Let us continue and write off the program for binary search. I will directly dwell into the program, so carefully watch it. Here I have a class called binary search. Inside the class binary search, I have the main method, public static void main, which would accept string of args inside the main method. Because I will take several inputs from the keyboard, I need the scanner object, hence scanner. Scan equals to new scanner of system.in. Next, I have to search the key in the array. If I have to search the key in the array using binary search, first array must be there. To create the array, first I will ask the length to the user like this. System.out.println, enter array length. By seeing this message, user will enter the array length. I would collect it by telling scan.nextInt, and I would store it in a variable called as n, which is of type integer. That is what I would do. Probably I will create the array now by telling JVM, I need a new integer array as the same length specified by the user, which is stored in n. For that array, I will give the name as ARR, which is of type int. ARR is an array of integer. Array is ready, in that elements are not there. What will I search? So I will ask the user system.out.println, enter array elements. By seeing this message, user will enter the array elements. I will collect it by telling start collecting the elements from 0th index, go until array.length -1 I++. Every time tell to the user to enter an element. By seeing this message, he would enter. You collect it by using the scanner object that you have created and store it probably in that array of ith index. Closing the for. Okay, sir. Next what? Now you have the array in that elements are also there. Next, what do you want is the key to search. So ask to the user system.out.println, enter key to search. By seeing this message, user will enter the key to search. You have to collect it by telling scan.nextInt and store it in a variable called as key, which is of type integer. Say supposing length is 6, user has entered 10, 20, 30, 40, 50, 60 and user has entered one key, probably 30. He has entered a key. Now, you have to search whether this key is present in this array or not. In two ways you can search. Either you can go for linear search or you can go for binary search. Linear search is inefficient, so let us go for binary search. What did binary search algorithm tell us? This is what it told us. Have a variable called as low pointing to 0th index. Have a variable called as high pointing to the last index. Done. Point to the last index. Next, you have to calculate mid. How will you calculate mid? Like this. Mid will always be equals to low plus high by 2. Once you calculate mid, please check if at all the key matches with array of mid or not. If it matches, really fantastic. Tell to the user system.out.println key found. At the index, whatever is there in mid. Well, if it is not matching, you have to check. Else, if at all, the key is greater than the array of mid. If it is greater, what you have to do? You have to bring low to one step ahead of mid. Let the high be there only. If it is not greater, say supposing if it is lesser, then else, if it is lesser, else make high to point to one level less than mid. Let low be there only. Let low be there only. This you have to do again and again and again as long as means while. Always remember. As long as means while. So, this you have to do as long as the low is less than or equals to high. Again and again you have to repeat, but until when? Until low is less than or equals to high you repeat. If low becomes greater than high, then control will come out. As soon as control comes out, here you can tell system.out.println key not found. If low becomes greater than high, control will come out. That is how it works. Anyway, key not found also we have told of. This is the opening of the main method, possibly closing of the main method, closing of the class. That's it. Using the binary search algorithm, we have actually searched whether element is there or not. If element is there, we are printing key found. If element is not there, we are telling key not found. Will it work? Might be your question. Many things again are there for me to tell. So, first let us open the Eclipse. And you can see same program is typed. Same program is typed. I will right click, run as Java application. It is asking enter array length. Same 6. Enter an element, it is asking 10, 20, 30, 40, 50, 60. 6 elements I have entered. It is asking me for the key. First I will enter 100. 100. Is 100 present? No, it is not present. Enter. Key not found. Correct only. I will re-execute it. Again it is asking me for the length. Again I would tell 6 only. Enter an element 10, 20, 30, 40, 50, 60. Enter key to search. Probably I will enter 5. Is 5 present? No, it is not present. I will click on enter. Key not found. Say supposing I will re-execute it. Again execute it. Enter the array length 6, 10, 20, 30, 40, 50, 60. Key 30. Is 30 present? Yes, it is present. Click on enter. Like this you would get the output. Key found, key not found, both you are getting. How to overcome this in the previous example only we have seen, or previous session only we have seen. That whenever the key is found, stop it. Don't continue. Because low is less than or equals to high. Until low becomes greater than high, you will be continuing off even though the key is found. So, better what you have to do is once key is found, tell system dot exit of 0. That is the opening of the if, this is the closing of the if. Once key is found, why should you continue again searching? Come out of the program. Now if I will re-execute it, look at it, re-execute it, yeah. Here, array length 6, elements 10, 20, 30, 40, 50, 60. I will give the key as 30. I will click on enter. Key found. Correct. It is working properly. Correct. Is it working properly? Working properly. Again I will re-execute. I have a point to tell. This is the very important point. Again I will re-execute. Enter array length 6. Enter an element 30, 10, 20, 40, 50, 60. Enter the key to search, probably 30. What should be the output? Is 30 there in the array? Did we enter 30? Yes. But if I click on enter, key not found you would get. If you ask me, sir, why sir? 30 we have entered, key not found, it is coming. Why? Why? Because you have not given the input in the ascending order. Remember this point very, very well. If your binary search has to work properly, I repeat, if your binary search has to work properly, then the input you have to give in the ascending order only, like this. If you carefully see all the cases that I have explained it to you, always I have taken the input in the ascending order only. I have not taken it in the descending order or some random order. Now what did I give the input? 30, 20, 10, 30, 10, 20, 40, 50, 60. How is it in the ascending order? If you will not give the input in the ascending order, your binary search will not come. Why sir? Why you only see? Always you are calculating mid. You are checking whether key is greater than mid or less than mid. Means all this side should be greater, all this side should be lesser. If this side all the elements lesser, this side all the elements greater, if it has to be in the ascending order only, it should be no. I hope I am completely clear with the problem of binary search. Binary search expects the input to be in the ascending order. If you will not give the input in the ascending order, your binary search will not work. Point number 1. Point number 2. Why binary search is called as binary search? This is the array, correct? What did we do? What will we do initially? Low here, I here. We'll calculate mid, correct? Mid means we are dividing the array exactly at the middle. We'll calculate mid. Then what we will do? We will check whether the element is in the this half or in the this half, correct? That is what we do. Whether element is that side or this side, that is what we will check. Say supposing element is this side. Again what we will do? Again we will divide the array into 2. Now this is the new array for us because this is low, this is high. Again we will divide the array into 2. Am I not correct? If it is this side, suppose this side, then we will bring high this side. So again we will divide the array into 2 exactly at the between. Always we will divide the array, we will divide the array into exactly 2 halves. It is by means to binary search. Because every time we are dividing and searching, we are dividing and searching, we are dividing and searching. The third point. Okay sir, binary search always expects the input to be in the ascending order. What if the user gives the input in the non-ascending order, means in some random order? It will be your duty to order it properly in the ascending order and give it to binary search. It will be your duty to sort it in the ascending order and give it to the binary search. How to sort, sir? Input that fellow gave of 30, 10, 20, 30, 40, 50, 60. How will I sort in the ascending order? By using sorting algorithms. You have bubble sort, you have selection sort, you have insertion sort, many sorting algorithms you have. Sorting algorithm means arranging algorithm, arranging in ascending order or descending order. Many sorting algorithms you have. You have to use any one of the algorithm and you have to sort it and give it. We don't know that algorithm, no sir. I am here to teach, no sir. That is why I am here. How to sort and give it to binary search if the input is not in the ascending order. Say supposing in the haphazard order the contents are there in the array. How to place it in the ascending order after placing how to give to binary search. That is what we have to learn in the next session. How to sort the contents. How to arrange it in the ascending order. That is what we have to learn in the next session. I hope I am completely clear, and remember, very important algorithms I am teaching you whether you know it or not. Searching and sorting algorithms are very important. Really they are very important. Tell me one such app that is present in your phone does not have searching and sorting. Contacts is a software you have searching, WhatsApp you have searching. Gmail you have searching, sorting. One application you show me which is present in your phone which does not have the searching and sorting. You have it. Searching and sorting algorithms are really very important with respect to a software developer. That is why I am teaching you the searching and sorting algorithms. I hope two algorithms by now, which is linear search and binary search, is clear. How do you do linear search? Start from the 0th index. Go until the last index every time one by one, compare and search. Compare, go and search. That is linear search. How will you do binary search? Binary search is very simple. Make a variable called as low to point to 0, high to point to the length minus 1. After pointing, calculate mid. Once you calculate mid, check whether the key is matching with A of mid. If it is matching, good, tell key is found. If it is not matching, check whether key is greater than array of mid or less than array of mid. If it is greater than array of mid, make low to point to one step ahead of mid. Then again calculate mid and check. If it is lesser than array of mid, then make high point to one level before the mid. Then again calculate mid and continue. This process of calculating the mid, making low come this side, making high come this side, all those things you have to repeat again and again and again, as long as low is less than or equals to high. If low becomes greater, immediately come out and tell key not found. Like this, you have to generate the art of telling the algorithm. Interviewer will ask, can you please tell binary search algorithm? You have to tell it. You have to explain it through words. That is when they will understand that you are logically sound. Something is running here. Something is coming out from here. How to do? He know how to type it. That conclusion they will come off. I hope I am completely clear about linear search, binary search. Next, we will learn sorting. Copy this as it is. For today, we will be stopping it here. In the next session, we will meet you. Until next session, please do take care of yourself. Happy coding and goodbye.